Welcome to our second STEM module. In this module, we will first talk about integrating STEM subjects in your projects, and second, we will examine why projects are so central to the development of STEM education. We will also encourage you to take your second step in the development of your very own STEM project. Our first major concern is the importance of thinking carefully about STEM subjects. As you recall from our first module, the need for STEM education grows out of the dilemma facing modern educators. How do we help our students learn to bring together subject knowledge in fluid ways, in ways that can creatively address pressing 21st century problems? How can we prepare students to support the scientific progress needed to drive, quote, innovation-based growth, as the President's report on STEM education for America's future asks? STEM projects bring together content knowledge in at least two of the content areas in imaginative ways, and they give students an opportunity to apply their knowledge to solve a real-world problem. But bringing together different bodies of knowledge to address real-world problems is not easy. For instance, engineering is a relatively new discipline for many teachers, while mathematics and science are more carefully defined with known curriculum. And technology can mean many things, from strategic ideas about achieving particular goals with tools to the actual use of specific tools themselves. The National Research Council, for instance, defines technology as, quote, any modification of the natural world made to fulfill human needs or desires. Many STEM projects focus on science or mathematics, but the challenge is to integrate more than these two subjects and to integrate them through a problem-solving process involved in implementing a project. And while you are designing, it is important to acknowledge that each of these subject areas is different. There are different epistemological characteristics, and according to Hirschbach, these differences must be acknowledged to, quote, preserve the intellectual integrity of each field. At the same time, there are some important connections in practices between these four fields, and we will discuss these connections in our next module. STEM does not represent a curriculum per se, but rather a way to think about designing educational learning environments. So it is really important to think carefully about how to identify the different disciplines you will use, the disciplinary focus from each of them, and how to integrate the ideas from the various subjects. This is our first major concern for developing ideas for STEM learning, bringing together the disciplines in a way that respects the disciplinary knowledge while creating a project that uses the knowledge in an integrated way. Our second major challenge is the design process itself. Often, STEM projects are focused on solving an issue that students know about or are experiencing in their school or community, also known as an authentic problem. Perhaps, for instance, you could investigate why the stream that is close to the school routinely floods, or why the area around the school is so noisy. What is the source of that noise pollution? Thus, STEM projects emphasize the application of content knowledge to solve a real-world problem. Ideally, STEM projects involve a team of teachers who can work together on a big idea that provides a foundation for the project. Perhaps in the upper grades, this would mean teachers from various STEM disciplines might come together to develop a STEM or STEAM project. Teacher collaboration can be a central aspect of STEM project work, but it is not essential. Individual teachers can start the process by creating and implementing wonderful STEM projects. So to get started, think about what you might want to do to organize the creation of new project ideas focused on solving an authentic problem using at least two of the STEM subjects. If you want to see another example of a STEM project, we currently have a National Science Foundation Design and Development Grant. In this module, we have included a short film developed for a video showcase to capture the work. This NSF project uses the model we have developed over the last 15 years, design, situate, lead, and explores how this model applies to the development of STEM activities in schools. Teachers design projects that are situated in their own individual school and classroom. Throughout the process, we emphasize the importance of teacher leadership and principal leadership in the development of authentic STEM projects. In our STEM application section for this module, Steve Azika is rolling out Stage 1. He will describe the understandings he developed for his project and, quote, what students will know and, quote, what students will be able to do in the backward planning approach. Please listen to Steve's explanation of the process and think about how it might be helpful in the development of your project. Please proceed with the development of these three sections for your project: the understandings, what students will know, and what students will be able to do. Enjoy this creative activity. We look forward to seeing you in Module 3.